My name is Krithika Gopal. I'm the product manager for APEX Block Storage at Dell Technologies. And I'm really excited to be sharing about some of the amazing things that we have been building over years with respect to APEX Block Storage and the whole universal storage layer concept. So in the last session, you may have heard Pratish talk about the universal storage layer and how we are bringing some of the industry leading Dell storage to the public cloud, right? Which is essentially the ground to cloud. And as part of that, the very first product we brought to market is Dell APEX Block Storage. Dell APEX Block Storage is based on PowerFlex IP that some of you may have heard about, right? So it's essentially a software-defined storage from Dell that's been around for over a decade. And customers love it for the performance it offers, the scalability, and the extreme flexibility. Right now, we want to bring all these features to the public cloud and extend the same benefits for the customers deploying in the public cloud as well. With Apex Block Storage, before we get into what's good about it, the features and things like that, it is available for both AWS and Azure, and it's available in the marketplaces, the respective marketplaces. If our customers are looking to draw down on the cloud commit, they can actually go to the marketplaces and purchase the software. Alternatively, if they choose to purchase it directly from Dell, that is available as well. With Apex Block Storage, one of the main goal is to help customers lower the overall TCO, right? And along with that, we also wanted to help them bring some of the applications that are currently, that otherwise they cannot take it to the public cloud because of performance SLAs and things like that, right? So specifically mission critical applications which demand high IOPS and that are latency sensitive, we are able to help them take those kind of applications to the public cloud. And thirdly, we also heard about the seamless data mobility across hyperscalers and also between on-prem and cloud. That is possible as well using native set of tools. And with Apex Block Storage, I definitely want to call out a very unique functionality that's called multi-AZ durability. And with this, we are able to increase the overall resiliency of the storage cluster. And we'll talk about it in the next few minutes. And finally, with Apex Block Storage, we are actually able to help the customers consolidate a wide variety of workloads. It could be databases, it could be analytics, it could be clinical applications, right? So any type of workloads, we are essentially helping them consolidate and put it in the single storage cluster, if you may.
There's a number that jumps out at me there.
Is it 100?
100x better performance, but I see the little 3, which means there's some more information there. Can you explain what you're referring to when you say 100x better performance?
Absolutely, absolutely. That's a great question. And one of the things that we really boast about Apex Block Storage is the performance, right? As I said, and we have a lot of performance data to share with you, and that'll kind of explain on what this 100x means. So essentially, we are with Apex Block Storage, and I don't want to get into too much of the details since we have a lot of that information being covered.
Okay.
Essentially, it is scalable, highly scalable to hundreds of nodes, right? And with that, we are able to achieve millions of IOPS that is not possible in the public cloud at this time. And when we did a comparison, based on the internal testing, we were able to see that a single volume within a single cluster was able to deliver 100 times or more than the existing public cloud storage.
Okay.
And then I'll share the data points in just a few minutes.
Okay, excellent. Thank you.
I'm actually curious about the pre-committed cloud spend, leveraging that.
Sure. So that essentially means that, since we are available in the Amazon and the Azure marketplace, you can, if customers have a pre-committed cloud spend and they want to draw down on the cloud spend, we actually let them purchase not only the hyperscaler infrastructure, but also the software, the Dell software, which is Apex Block Storage, with the hyperscaler and draw down on the spend.
So it goes towards their EDP.
Exactly. So in terms of Apex Block Storage, one of the things that I want to call out is we are not competing with the public cloud, right? So we are essentially working with the hyperscalers, and we want to elevate the customer's experience in their cloud journey, right? So we are deploying our software in the public cloud infrastructure, and we want to help our customers for unique scenarios which are currently otherwise not addressed in the public cloud, right? So one of the things that I called out, and I keep repeating myself on the performance and scalability, and I'll continue to do so in the rest of my session. we are able to deliver extreme performance. We are not really like, talking about like, few hundred thousands, but we are talking in millions. So we are able to deliver this extreme performance on-prem, and we are extending the same thing in the public cloud as well, right? So if customers are looking to deploy their mission-critical applications that demand extreme IOPS and sub-millisecond latency, we are able to achieve that in the public cloud as well. And improving resiliency. So customers are used to a certain kind of resiliency on-prem, right? 6 nines has been a norm for decades, and we are able to achieve the same thing in the public cloud using very cheaper storage. That's the best part of it. Using our native data protection and other functionalities, we are able to extend the same level of resiliency even in the public cloud. Predictable costs. This is one of the concerns that we often hear, right? So we don't charge for the IOPS. We are able to utilize the instances and deliver all the IOPS that it has to offer. We don't charge for the IOPS. And thus, customers can expect predictable costs when they are deploying their cluster in the cloud. Seamless data mobility. Again, we have similar set of management tools, APIs, and automation tools. So you have native functionalities as well, which you can use to move your data irrespective of where the data is. It could be on-prem, it could be in the cloud or in the edge. And finally, consistent tools. Like I said, the same management interface you are used to on-prem, you can use it in the cloud as well. One of the things that we hear very often from the customers is they have the data on-prem and they are looking to move to a couple of hyperscalers, right? So that is the whole multi-cloud that was being discussed before. And when they are placing the data across multiple hyperscalers, one of the things they are missing out is now they have to go and build a separate set of APIs and tools for those specific hyperscalers. And with APEX Block Storage, we are giving the consistent experience to our customers, irrespective of where the data is.
I have a quick question while that switches over.
Sure.
I was wondering, since for anyone out there that may be wondering online, I see that we see AWS and Azure, and I was wondering, what about Google?
Absolutely. That's a great question. We launched APEX Block Storage for AWS in calendar year 22. Last year in October, we added support for Azure. So GCP is definitely in our roadmap, and we are looking to address that in future.
Cool.
Thank you.
So if I can go back, and there's variations of VBS, right?
Absolutely.
Me, you've got all the way down to disk. What is that number coming from, and what are you comparing to what?
I will definitely share more details in the next few slides, but to answer your question, we picked the best-in-class EBS, which is IO2 Block Express.
Okay.
Yeah.
Okay. Then the other thing is that you stated that you were using the same SDS that you have on-prem in the cloud.
Yeah.
For clarification, is that pure PowerScale SDS, or is APEX Block that's on-prem different than PowerScale SDS?
That's a great question, and I'm really glad you brought it up. So it is PowerFlex. PowerScale is the file, the Dell file storage. So this is PowerFlex. Yep.
I do that all the time with those two. Okay, it's PowerFlex, which is Scale IO, which is why it confuses
Exactly.
me completely. You guys should never have done that branding. I cannot do. I know I'm thinking Scale IO when I'm saying it, but okay. So
you're right. So it's Scale IO.
That is Scale IO. That is your APEX Block Storage on-prem. Is that the same code on-prem with APEX Block in the cloud? And is it that the same code lines for PowerFlex?
Exactly. And that's a great question. And thank you so much for asking that. The APEX Block Storage that we deploy in the public cloud is exactly the same code that we have on-prem.
Okay.
And the best part is PowerFlex, as you may have heard of, and Scale IO, right? By design, it's a software-defined storage.
Yeah.
It can be deployed on any x86 server, right? We use that principle. We just treated the hyperscaler infrastructure as yet another x86 environment, and we deployed it. We didn't have to re-architect the code at all to be deployed in the public cloud, right?
Did you have to do anything with AWS or Azure in terms of the architecture of the hardware that you're based on? Because I know you had to do that with Isilon.
We didn't have to, honestly, we didn't have to do anything. I mean, we could pick the PowerFlex software.
You just dropped it on what?
So we actually have validated with two types of instances. Technically, I can deploy it anywhere, right, on any instance, but we pick the i3 instances, and then I'll get to that.
Okay.
Probably it'll make more sense like when I'm explaining how it is deployed. We pick two instances, C5N instances and the i3N instances. So I'll explain what the difference is between the two, but we picked these two instance types because we want to deliver the best performance, right? So we kind of like did an analysis on what delivers the best performance for the dollar, and I identified these two instances. But technically, we can go ahead and deploy the software on any type of instance.
Yeah, I could keep digging, but the next one would be, can I replicate between AWS and Azure?
Technically, you can, right? So we just have to work on the legalities of moving the data across the hyperscalers.
Egress fees.
Yeah, but our software features allows you to replicate from on-prem to the cloud, across regions within the cloud. So anything is possible. We have tested that; it works, but we have to work on the legality of that.
Okay, thank you.
So from that perspective, you're talking about legalities and more like business process to overcome. I remember like years ago when this was still Scale.io, maybe even before it was acquired, some SE somewhere basically put it in AWS, test it out and see what it could do, and achieved many of the claims that you're talking about now. That was years ago. What, like, from a timing perspective, why is it taking this long to productize it?
Essentially, like, I mean, that's a great question, right? In fact, I will tell you that, we have done some of the tests even before we productized it, because it's easier to, like, stand up a cluster as opposed to identifying the hardware, right? So we have done that. Why did it take this long? Essentially, like, as a team, like, as a organization, we had to, like, work on our strategy on specifically, like, what is that product we are taking to the cloud, right? Like, as you are aware, we have many amazing products within the Dell portfolio, right? And essentially, as part of the universal storage layer, we want to make sure that we are taking the best IP to the public cloud that will solve for various needs, right? And that took time, and essentially the whole productization, right? Working with hyperscalers, identifying the instance types or even the virtual machines, and building all the productization, being able to like transact with the hyperscalers and with the customers. So those are some of the productization aspect of it that essentially took us a little longer. So moving on to the overview, right? So I talked about APEX Block Storage. I think I covered some of the aspects of how we deploy it in the hyper scalar infrastructure, based on the Q&A we had. But we actually take the APEX Block Storage software and deploy it on AWS EC2 instances. And we have two flavors of deployment that we offer to the customers, right? One of it is deploying the software on EC2 instances and consuming the EBS volumes, essentially attaching EBS volumes, GP3 in this case, and aggregating multiple EC2 instances in order to create the APEX Block Storage cluster, right? So that is called the balanced option. It offers a balanced performance, right? The advantage of that is EBS volume, as you are aware, it's a persistent storage, right? The second option we have is performance optimized, and that utilizes what Amazon calls as EC2 instant stores, right? And that comes with locally attached NVMe SSDs. They're extreme, they can deliver extreme performance. We essentially aggregate a bunch of those EC2 instant stores. We can start with a minimum of 3, and the best part with APEX Block Storage is it can go up to 512 storage nodes, right? And we are able to aggregate a bunch of them and create a cluster. The only caveat there is the EC2, the NVMe SSDs are ephemeral in nature. So if you have a transient workload, if you have to constantly shut down your cluster and things like that, then you have to back up your data, right? So that's kind of the caveat there. Same thing with the Microsoft Azure architecture as well. So we deploy the software on virtual machines and attach the premium SSD V2s for the persistent configuration or the balanced configuration. Likewise, we have a performance optimized in the Azure infrastructure as well, wherein we utilize the virtual machines that comes with locally attached NVMe SSDs. I think the L32s and the L64s that comes with the NVMe SSDs, and we create a APEX Block Storage cluster based on that, right? And with this, we have also validated Dell Data Domain Virtual Edition. So if you are creating or taking any APEX Block Storage snapshots, you can actually back it up to a cheaper media such as S3 using DTVE. Now let's look at some of the key use cases on why or how customers are using this, right? With APEX Block Storage, the most common use cases is database workloads, right, which demands that sub-millisecond latency. Workloads like such as SQL, Oracle, and so on. So those are some of the applications that benefit from the performance that APEX Block Storage delivers, right? Analytics applications. So, if you want to run analytics workloads, that's another great use case. We have customers who have their production on-prem and want to do the test and dev in the public cloud. That's another great use case as well. So we have customers using running clinical applications that demands the sub-millisecond latency. And they utilize the APEX Block Storage performance.
So I have a question around this sort of sub-millisecond latency and the way you're achieving that, because it sounds like you're essentially building a storage array.
Right.
In the cloud, and then other EC2 instances or Azure VMs are consuming that storage array. So what type of connectivity am I expected to have between the Azure VMs consuming the storage and this storage array you've built to get that sub-millisecond latency? Because I'm thinking, wouldn't I just attach a local NVMe drive to those Azure VMs to get even faster storage? How is it faster across the network than something that's attached to the VM locally?
Right. So, by design, PowerFlex has a mesh mirror architecture, right? So, and then we have the storage nodes are essentially what we call as SDS. We aggregate a bunch of these storage nodes, which we call storage data server, and then we have it's a proprietary host. It's not the standard like iSCSI or the fiber channel host, but we have what we call as storage data clients, SDCs, that gets deployed essentially, in the compute instances that you're bringing where the applications resides.
Okay.
And, essentially those SDCs consume the volumes that you create on your SDS nodes.
Okay, so you're not provisioning this using the cloud tools to attach volumes. You're using this SDC software that has to be deployed on each VM to connect in and consume it. And do you have recommendations around placement of those virtual machines in regards to the cluster? Should they go in the same availability zone or zone if you're in Azure because they call it something different? Should they be in a placement group? Is there advice around that to get maximum performance?
So to be very honest, we don't have any specific requirement around having it in the same placement zone. But technically, if you are sticking with the same region, then it's more advisable. We do pretty well with the multi-AZ placement, but as long as it is not in a different region, I think we'll avoid the latencies.
And this is all happening across the network.
Right.
So I have to, in my mind, think about the egress charges between availability zones.
You're right, but to be very honest, I think it's very small, right? It's like 1 cent a gig, the data transfer cost. But yeah, I mean, if we are, again, I'll get into the details. So, perhaps that's a great segue for me to explain about the different deployment options, which will also be covered. But, you have a choice to put the entire storage cluster within a single availability zone, or you can actually stretch that cluster across multiple availability zones. I'll explain how we do that in the next few slides. So you have an option. If you are comfortable with the single availability zone resiliency, great, you can put everything within that. But if you want that multi-availability zone resiliency, then we stretch it. And then, to answer your question, yes, we do have that 1 cent or whatever that charge is across the AZs. But, you also have to think about the capacity charges that we are saving on. Like, we are not requiring additional capacity when we are deploying ourselves on a multi-AZ. I'll get to that in a minute. Probably that'll explain it. But we have a lot more advantages in deploying a multi-AZ configuration as opposed to a single AZ.
I'm just thinking through the cost implications for myself. If I was comparing apples to apples in terms of performance, what does it look like from a cost perspective? And I can't forget about that network egress charge if I'm doing a multi-AZ deployment.
You're right. Yeah.
Can I have a question about this client software that you sell on the computer? it's basically piece of the software on the driver's level, or it's a daemon? How is the form of this client software that
So
is access to
it's
the
an
storage?
it's a package that gets installed in the EC2 instances, right? In case of Amazon, and it's wherever you have your application resides, and you essentially think of it as a host that you're mapping to a volume, block volume.
Sure, and because of this piece of software is working on the instance, it will consume some of the resources of the instance.
It's very minimal though. It's very, very minimal. I mean, I can share like, papers that explain how, but like it's very minimal.
Another question there, do you need a local buffer?
No caching required.
No caching required on the instance.
Right.
So
Nothing.
basically, it's just a piece of software that connect you to the Scale.io platform.
Storage nodes. Exactly. Exactly.
Okay, thank you.
Thank you.
And just on that note, then, does that mean that my clients can only be EC2 instances or virtual machines, or can I connect other cloud native solutions to the storage if I wanted to leverage the APEX storage system for other cloud?
Are you essentially talking about, do we have integration with the other cloud services? Like, I mean, I think technically you should be able to, to be very honest, we haven't validated a lot because we've not heard of asks. But yeah, I mean, if there is a customer requirement, then definitely we'll go ahead and we're not integrated per se, but if any of the services are, can work with that, then we can certainly validate that. Like a cloud watch or something like that.
A lot of those services don't consume block storage, right? They're expecting object storage.
But this serves up.
This is serving a block storage.
Yeah, okay. Only block.
I think I saw on an earlier slide that there's also an object
that's
storage solution,
I thought
but
I saw
this is
file.
pure block.
Right. So yeah, perhaps I should clarify those. So as part of our universal storage layer, story, our aim is to take Dell's block, file, object, and the protection, software solutions to the public cloud, right? And in this specific session that I'm talking about, we are specifically focusing on the block storage.
Got it. Okay, sorry. Yeah. Cool.
So the question on your availability number, what's required for that availability of 6 nines? So is that assuming a replication to another AZ, or what kind of setup are you looking at?
We are not requiring any replication. That's not factored in. So essentially, our product is designed to deliver, whether it's on-prem, right, or in the cloud, it is designed to deliver 6 nines. And we have actually, if they are using what we validated, which is the i3EN instances or the C5N instances with EBS volumes attached, through our data protection strategy, we are able to meet with the 6 nines.
And is that in your SLA that you're delivering in the contract?
To be very honest, I don't know if any of the storage vendor guarantees, right? So because when we talk about the availability, it depends on so many other factors.
Well, they do have. That's why I'm asking, what are the factors that you're guaranteeing on, and what is the how you're guaranteeing that? Because normally, if you were on-prem and you own the box,
exactly,
you got the box, but you don't own. You don't own the AZ and that kind of stuff. So where's the liability limitation, et cetera?
Right. It depends on various factors. And right, I mean, from the storage node perspective, based on what we see,
it's the code.
Guarantee. But there are so many other factors that form the entire infrastructure. And so.
But so the funny part of that, though, then comparison, if your availability number is really based on your code availability, right? Your code,
right?
SDS. And you're not measuring yourself down to the hardware because you don't own the hardware.
Right.
They're measuring themselves down to the hardware. So that's not an apples to apples availability number.
You have a valid point.
Okay. Yeah. Okay. So that's and then we just went down again.
I mean, just to pile on to Camberley's point, typical SLA for a public cloud is 3 nines availability. If you go to AWS, that's what they'll give you.
Right.
There's that's the network, that's the data.
Exactly. That's right.
I mean, your one small part of it might be 6 nines, but that doesn't translate to service availability.
That is true. We are really talking about the storage.
Maybe clarifying what you mean so you don't
Right, right. I mean, I think his point is like, very valid, which is like, we are strictly talking about the storage part of it,
Yeah.
not factoring in the networking and the other
Yeah,
aspects.
and I think it's it's an understandable situation when we get up to the cloud. When we start stacking stuff up on the cloud, there's so many variables in that piece of it. It's
Absolutely. Yep.
it's one of the wonderful things about it.